Go.
Okay, so welcome to Plastics Semi-Advanced Part 2. So today we're going to be talking about polystyrene, polyvinyl chloride, any low-density plastic, and low-density polyethylene. I think that was a bit of typo. Anyways, first things first, we're going to do polystyrene. Now, polystyrene has recycle symbol 6, and its abbreviation is PS. Now, like others, it has atactic, isotactic, and stereotactic, like polypropylene that we discussed in the previous video. Now, most of the time it's atactic, and we can't really control if it's isotactic or stereotactic or just random. Here's the monomer. Now you can see that this is the part that breaks, this double bond here that breaks it. Because now you might wonder why the benzene ring breaks. It's because that it's like the structure makes the benzene ring very stable, so it's only this part that breaks. So this is the monomer, as you can see. And then when 6 breaks, we can have another broken up styrene over here, and then it connects on, as you can see there. So that's the monomer, and now we're going to see the atactic form, or that's what most polystyrene is. It just like randomly chooses backwards and forwards. Now polystyrene is also in styrofoam, which is basically like polystyrene with like bubbles in it, which is why it makes it so puffy like. But polystyrene is in styrofoam, and in polystyrene is one of the more toxic plastics. Now, all plastics are toxic, but the ones we're talking about today are are kind of toxic. Now, that's polystyrene. Next, polyvinyl chloride. Recycle symbol 3. It's basically ethylene, except that it's basically propylene, except that here there's a chlorine, which makes it a chloride. Now, as you can see here, it is mainly atactic, and we can't really control what it is. Now, it has recycle symbol 3 and is one of the most toxic plastics. Polyvinyl chloride is basically used everywhere, like in refrigerator stuff and stuff like that. And it's also used in stuff like plastics for putting food and stuff inside it. And yeah, that's polyvinyl chloride. Oh yes, and it's also used in fake artificial trees, Christmas trees, and it's also used in vinyl. Anyways, next, linear low-density polyethylene. Now, you might wonder why it's called linear low-density polyethylene. It has recycle symbol 4, same as low-density polyethylene. It's just that the abbreviation oh, I forgot to mention the abbreviation is PVC, but this, anyway, it's LLDP, but this is LDPE. Now, linear low-density polyethylene, its monomer looks like this, but this is just a hexane. And you might want to review a bit of the functional groups episode, but it can be an octane, nonane, and a decene. It can be however long as it is, but for now we're just going to be simple and stick with hexane. So now we have the main atactic form, and and then I forgot to show what was that? Oh yeah, stereochemistry, but you can basically get the idea that it's like not back and forth, it's just at random, and that's just non-linear. Now, this is what makes it low density, because if you put a bunch of these together, they're not straight, so they can't pack together very well. So that's what makes it low density, and it's also linear, as you can see. Lastly, we have low density polyethylene, recycle symbol number 4. Its abbreviation is LDPE, and it's very similar to high density polyethylene, except for one thing. Now, I made this hydrogen pink because I want you to focus on that hydrogen. I want you to watch your eyes on that part. So here's what makes it different. The other side, this carbon is missing a bond. So in this case, the carbon can steal this one, and then it's complete. But now there's a problem. Now this is not complete. So we have more polyethylene joined over here, and it has this sort of branching sort of thing. And then the same thing can happen over and over again, and this is what makes low density polyethylene low density, because when there are a bunch of these, they can't pack very well because of the branching and all that, which makes it hard. Now, as you can see, we can repeat the same process over here. We're gonna do a bright color. Okay, you're not gonna see that. We're just gonna make a different color, and then once that happens, you see that when the H, and then as you can see, we can do the same thing again. This goes here, this. Oh, why can't I get it to move? It goes here, and then now we see this is the problem, so it just can, low density polyethylene just keep going all the way there. Now, as you can see, that is the basic idea of low density polyethylene. When they pack together, they can't pack very tight, so that's why it's low density. And now we're just gonna do a quick review, and then it'll be over. So first, we have polystyrene, recycle symbol 6, and its monomer is a benzene with a carbon sticking off it, like this, with a double bond, as you can see. So I'm bad at drawing hexagons, you know. So okay, that's definitely not good looking, but that's the best I can do. And anyways, that's polystyrene, and it is notice how all of these, it's all atactic. You can't really control on except for the low density polyethylene, since there is no stereochemistry in it. But for the rest, as you can see, there are different ways on where you can put the double bond, which is what makes it atactic. It's just where you can break the double bond. For example, back in polyvinyl chloride, you can see either break this one or this one. And if in this polystyrene, you can also break that, which is what makes the stereochemistry. Then they're pointing away, some of the side chains are pointing towards you. And then we have polyvinyl chloride, which is, remember, recycle symbol C, PVC. Now, polystyrene, remember, used in stuff like styrofoam. It's bubbly, and polystyrene is, used a lot in different places. PVC is used in stuff like a refrigerator and tubes and the coating on electrical wires. And its monomer is this. I'm not going to highlight these carbons so that we either to visualize, but we don't usually. And then, as you remember, here's the polymer form, as you can see here. Good. And now we have the true low density polyethylene. This is the LLDPE. At first I saw there's an extra L printed, then I realized it is a different thing when I was first learning this. So, as you can see, it's basically an ethylene, but there's just things sticking off of it. And it's basically high density polyethylene, except for these random things that randomly get stuck off. You can see here. And now, last but not least, we have recycle symbol 4 again. And we have the low density polyethylene, as you can see. Remember, it branches off, so this will need a bit of moving around. I'm just gonna do a quick overview, and then so here's how it works. Reminder: this carbon steals this hydrogen. Well, it's not exactly stealing. It's just like the hydrogen just, like, you know, gets there and stuff like that. It goes over here, then that leaves this incomplete and more polyethylene, and then it just keeps branching, which is why it's got low density, because they can't pack together very tightly. And that's it. So I see you in part 3.